Okay, so quick overview. We have two charges. They are separated a distance apart, and this simulation is measuring the force between those two charges, those two electrical charges. So we want to basically use this simulation, collect data from it, and figure out what the relationships here are between charge and force and between the distance and force, just like we did for gravitation. And we're going to use the positive physics inquiry part of it to kind of get started. So they kind of ask you some general questions that you can play around with the simulation with, but then they ask you a question about how much force there is between. Here it's an 8 microcoulomb charge and a 14 microcoulomb charge. Well, we can't get 14 microcoulombs on this, but we can get several things that are smaller than that. So we want to collect some data and see if there's a trend. So this says, okay, mine is 8 microcoulombs, 14 microcoulombs, and they're 5 centimeters apart. So I'm going to set this up to be 5 centimeters apart and make one 8 microcoulombs, and I'm going to manipulate the other one. So if it was 0, then, well, there'd be 0. So let's see. So my x, which is my independent variable, it's the thing I'm going to manipulate, is going to be charge. We typically use Q for charge because it's the quantity of charge. And then the y is going to be the force output. Okay, so at 0 charge, we have 0 force. Not very exciting. And if we put this up to 1 microcoulomb, we get 28.76 newtons of force. 2 microcoulombs, up this, and we get 57.52 newtons of force. Okay, and we start getting, let's see, let me zoom out a little bit here. There we go. So there's my 3 dots plotted. So I'm starting to get a trend line here, and I'm going to fill in the rest. Well, this is not pausing. So my point is, you're going to go 3 microcoulombs, 4 microcoulombs, 5 microcoulombs, 6 microcoulombs, all the way up to 10, and you should see basically a trend line. Maybe it's linear, maybe it's not linear, but you're looking for a relationship between the quantity of charge and the force involved. And you're going to kind of make an estimate for, okay, at 14 microcoulombs, we can't put that into simulation, but looking at the trend of the data, make an estimate for where you think it might be. For the next question, it has you looking at 5 microcoulombs and 10 microcoulombs, but 11 centimeters apart. Okay, so I'm going to set this to 5 and 7, right? 5 and 10. 5 and 10, not 7. At 11 centimeters apart. So now, for the second round, we're going to look at distance and force. And we'll look at a distance of, I can't quite get to 1 because I can't get the charges close enough, but I'm going to start at 2. So distance of 2, actually I'll do it here, distance of 2, and I'm going to go 3, 4, 5, 6, 7, 8, 9, all the way up to 10. I'm going to collect the data based on that. So at 2 centimeters, I have a force of 1123.4444. 3.4444. And then I move this to 3 centimeters, and I can move this ruler if you want to get it a little closer. And that drops down to 499.308. 499.308. So on and so forth. Let's see, 4 centimeters, we're at 280.861. Ready? So here again, where's my data? There's my data. All right, so one's all the way up here, and then another, and then another. So this is plotting my data here. What I'm looking for is a trend. How is this changing? How much is it changing each time? As you look at the number you're going to predict for, this is a tool to kind of help you see what are the numbers trending toward. We're looking for relationships, again, between charge and force and between distance and force. Force is always going to be your y dependent variable in this case. Have at it.